Anyway, this is the synchronization problem. There exists the shared data, but many processes would like to access. But condition is they need to get the kind of, this is kind of lock. How many lock? 2 locks. Okay? 2 chopsticks. So how can we address that problem? Using the semaphore. At the time we can define the 5 chopstick semaphore. 5 semaphore. So we can consider this is the also resource. Okay? This is a shared data. This is also shared resource. So this is has the lock. So using this, once the 2 of them are acquired, then get the this another resource. Okay, that may be happen in real operating system, and so this kind of the combination of the readers, writers, and producer and consumer problem. Okay, so how can we implement? There are many the solutions. So for example, this one is the simplest way. So if I get the log of mine and check the next one, right hand side, for example, either left hand side or right hand side, but one direction. Okay, so let's say the +1 means the right hand side. 1, 2, 3, 4, 5, something like that. Or 0, 1, 2, 3, 4. So right hand side. Check the right hand side. If I can get, if that process get the log of the chopstick in front of me and the next chopstick, then it access the critical, enter the critical section. Then that's done and release it. The problem can be whatever that is called a kind of, it's a deadlock. It's also kind of the deadlock. It may cause the deadlock. So another solution is, so we are going to define the mutex lock for 1. Rise 1, which means only one philosopher can access. Okay, which means only one philosopher can take the 2 chopsticks and eat the rice. So first you need to get the permission to eat the rice, to access the shared data set. Okay, then if yes, then you can enter. The problem, even though you have the available, only one can enter, can eat, can use the shared data. So I think there might be variation of the variation of the dining philosopher problem. So, but these 2 solutions are basic. But if we do not have such a semaphore in software level, it may be very, very complicated. So that is the example of how we can use the semaphore for the classical operating system synchronization problem. Okay, the main problem, as I said, the problem, this one is, should be wait and signal. However, sometimes if the developers are very lazy, they can forget the signal, or sometimes the opposite way, or just wait. That may cause the problem. It can be the lock forever, or it can be deadlock situation. Okay, so some of the operating system control, like the applying the timer, the expired time. For example, within 10 seconds or the minute, if that is not released, that is not called by the signal, automatically released. However, in general, this is a problem. How can we solve the problem? Using the monitor, the data structure. This is the last one. Monitor is kind of abstraction level, abstract data type that you have learned in your programming language, object-oriented program language, right? It's an abstract data type. Like for example, what is the typical class? In the class, you have the method 1, method 2, method 3, something like that. So we are going to borrow this way, okay? Abstract data type to define the 2 define the new data structure to solve the synchronization problem. How? So if you see, for example, this one, to enter the critical section, we need to control, even though we have the semaphore. Semaphore is the log of each resource, common resource, shared resource. So when you have the multiple resource and the other resource, you need to define you need to use such a semaphore for each and make the algorithm for exit and the enter and exit section. You need to define that still. Okay? Even though that is much simpler than the software solution. So why don't we make the data structure that can control each process, each shared data. So this one is the process 1. This one is process 2. Okay? So this is the monitor. So monitor is one data structure that includes such a shared resource inside. Okay? Have you ever seen similar one? Similar data structure before? Java. Java is like that, right? What about the C#? C# is like that. So that is the reason when you are using the object-oriented programming, that class can be accessed by how many threads? Only one thread can access it. What about the other thread? The other thread should wait until current thread is leaving. Okay? So actually, the Java object-oriented program, when they develop the new program language, they employ such a monitor idea. So monitor is kind of such an abstract level data type. Okay? So this is a schematic view of the monitor. So inside we have such an operation. Each operation should be controlled by the semaphore and the logic. But we are going to abstract, make the class kind of. That is the monitor. Then if there are processes who want to access the shared data through the operation, they need to wait. Okay, only one by one. Then they can call such an operation method to access the shared data. It's controlled by the monitor. Okay? One of the typical example is a Java class. Okay? Then problem, how many threads? Only one thread. And what about another thread? No guarantee. Okay? Should be a first come, first serve or something like that. So to address that one, we can have another variable inside the monitor, that is a condition variable. Condition variable is kind of queue to manage the thread who are requesting to access the shared data. Like if process want to access the shared data using the X, this operation is X condition. So this one is kind of queue, and another queue. So you can manage the queue inside for the class. Have you ever defined such a thing? No, you don't have to. Why? Because it's inherited. When Java developer develop the Java program, they define inside the class this monitor. So you don't have to worry about it. But you can still use their method. Through the method, you can control it. And so why don't you take a look at back your textbook, Java programming, probably is mentioned.
But you eventually get an abstract class. An abstract class, so you can only use one method out of that.
Oh yes, it varies. Okay, sometimes only one, or depending. Yes, how you can define this. This is just a general definition of the data structure. When the Java group adapted that one, only one. Okay, at that time mutants. Okay.
So you want us to relate the whole scenario to this?
Okay, so that is the variable for condition. This is a solution for the dining class support using the monitor. So we will see later very briefly about this one today. I'd like to have the pop-up quiz. This is it's 4 o'clock right now. So I'd like to give the 15 minutes. This is a pop-up quiz regarding to the chapter. As you may realize, there is no homework for the chapter 5. So this is the pop-up quiz. So you can use any material, including the internet or whatever. The cell phone or the do not discuss that. Do not discuss with your friend. The answer then submit to the TA. Don't